What time is it? It's science time.
Science time. Let's all stop and just unwind. 1, 2, 3, 4, here we go. Learn so much your brain explodes. Lessons so cool, so fresh. Beat so big you'll lose your breath. Learning facts and real cool stuff. Scream for more, can't get enough. It's science time. It's fun, you best believe. Explore and learn new things. Come and join me, please.
I'm Mr. C, and this super smart group is my science crew. Lila is our notebook navigator, Alfred is our experiment expert, Riley is our dynamite demonstrator, and London is our research wrangler. Working with my team is the best and makes learning so much fun. Actually, you should join us. Today, we're learning about friction. What time is it? It's science time. Welcome back to another episode of DIY Science Time. I'm Mr. C, and I'm so glad that you're here to be part of our crew today. We're talking about friction. You know, F-R-I-C-T-I-O-N, friction. F-R-I-C-T-I-O-N, friction. Yeah, friction is actually a really cool thing. It helps us in our everyday lives, but we also work to reduce friction at the same time. It's actually kind of weird to think about, but friction allows us to walk down the street. It allows our cars to drive down the road. It allows us to take our hands, put them together. Do this with me. Put your hands together and rub your hands together as hard as you can. Can you feel the heat that's being created? That's because of friction. Yeah, it's producing heat. And when we rub two objects together, they want to try to resist one another. And that's what we call friction. Friction! And today, we're actually going to build a hovercraft, and that means we need a few materials. Alfred, what do we need today?
Let's not let any friction slow us down today. We're building hovercrafts, and you're going to need the following materials: a piece of cardboard, a CD, balloons, a sport bottle lid with a pop-up top, a hot glue gun, scissors, and don't forget your science notebook!
A science notebook is a tool that every scientist should have, and it gives us a place to record all of our learning. Taking good notes and being organized allows us to be better scientists. A science notebook allows us to go back and review all the data and information we've gathered during our experiments. Plus, it allows us to share results with other scientists who might be interested in learning more about what we've discovered. Whenever you see the notebook pop up on the screen, like this, it's a reminder that this is a good place for us to jot down new information. You can see I've already added a title and a list of materials for today's activity. Our crew is still going to have lots of information to collect and organize as we go through the experiment, so keep your notebook handy. Most importantly, the more you use the science notebook, the better you'll get at taking notes and recording data. If you don't have a science notebook yet, download a copy of Mr. C's science notebook from the website.
First, we're going to trace this. And we're going to cut it out. So we have our circle. I'm actually going to use this circle as a template to find the center of my circle. And now I know where to cut that out. When you do this, be careful. You want to punch a hole through the center. And actually, I'm going to just leave it like that. So the part that popped up, I'm going to use this on the top here. So we have our cardboard here. If I put it on the table and I try to push it, it really doesn't go too far. And that's because of friction. These two things are rubbing against one another, and it's going to prevent the cardboard from sliding across the kitchen table. So what we're going to do now is we need to actually build ourselves a way to get air underneath here, to get a cushion of air. And that's where this sports bottle top comes in. So I can open it and let air come through. I can close it and the air will hold it. Doesn't work. So what we're gonna do is we're gonna glue this here on the center so that we can control the airflow to the bottom of our hovercraft. All right, and for this, you're going to need a little bit of glue. So I'm just going to run the glue around the ring here. And then put it right down over the center. And then I'm going to let it dry. And I'm going to take just a little bit more and run a bead around the outside just to make sure I have a good seal. And I'm going to let that sit just for a second. While that's cooling, let's talk about our engine for our hovercraft. Our balloon. So the balloon is going to power our hovercraft. And what's going to happen is we're going to twist this, put it on here, and it's going to let the air come out the bottom. But because it's going to be attached to that, it's going to push the air underneath this cardboard here to lift it, and it will hopefully allow it to float around on the table. All right, here we go. Let's go with the green balloon so we have some contrast. So I'm gonna blow it up. I'm gonna turn this around, twist it. That way I can put it on here. And because this lid is able to open and close, I don't have to worry about the air running. Well, I don't have it closed. There we go. So it's gonna race out just like that. All right, I'm gonna have to blow it back up. Ah! All right, we have a little bit of an issue. So when the balloon gets put onto this cap here, the balloon gets stuck between the seal. So when I went to push it closed, it wasn't allowing it to close. So it's just something you have to pay attention to. Every bottle cap is gonna behave a little bit differently. It's just something, part of the engineering design problem. Oops. Part of the engineering design process you just have to work out. All right, let's see if it works this time. Make sure it's pulled up. There we go. Oh, look at that. The balloon keeps tipping over. Let's try a different balloon. I think this balloon is just, here, I moved all my stuff so we had some space. I need to grab another balloon. Ah! Here's a blue balloon. Yeah, so the balloon is not as stretched out. I'm hoping that this does the trick. Here we go. Let it go. Oh yeah, look at that. I can push it. And then when the air runs out, it literally just stops because we have the friction come back into play between the table and the cardboard. The air is reducing that friction. Oh, that is so cool. You guys should build one of these for sure. You could try it with a circular hovercraft, a squarish hovercraft, a rectangular hovercraft. See which one works best. Have some fun and then make more, and you guys can have races with your friends and family. Oh yeah, Hovercraft Fun Friction. F-R-I-C-T-I-O-N, friction! Friction is the resistance one object experiences when moving over another surface or object. When the balloon is empty, the disc doesn't slide across the table as easily. The hovercraft pushes air downwards through the opening to create a cushion of air. That cushion of air reduces the friction between the disc and the tabletop and allows it to easily glide.
The hovercraft was invented by Sir Christopher Cockerell in 1955. Hovercrafts can travel over land, water, mud, and ice. I wonder if Mr. C's jumbo hovercraft can do all those things.
Check this out. What I thought we would do now is take our same concept, the table hoverboard, and turn it into a real life, huge monster hoverboard that we're gonna actually try to ride. I don't know if it's gonna work, but we're gonna give it a try.
Oh, yeah. It's time for some science DIY hovercraft. Oh my gosh. That is so hard to do because every time I move and I push, I'm changing my balance and it's causing the hovercraft to actually hit the ground. I think I'm just too heavy. Oh my gosh. Oh my gosh. That was awesome. So we need a bigger power source if we want to move me, because I'm just too big and too heavy. But my daughter, she made for a perfect passenger. And then when I was able to get her pushed properly, she was balanced and we're just gliding across the tennis courts. It's pretty awesome. That's what can happen with the power of air. Reducing friction is all about changing the way two objects are rubbing against one another. The air gives that cushion just like the tabletop hovercraft, and it's so much fun. I'm out of breath. Pushing her around the yard, well, not the yard, but the tennis court is something else. I think I'm gonna take a break. Whew. Yeah, friction, keep me in the seat, safe and sound.
Bowling alleys use wax on bowling lanes to reduce friction and allow bowling balls to glide and roll with ease. I'd say that's a strike. 3 strikes, you're a turkey. Gobble, 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 gobble.
I couldn't resist all of these forces anymore. Let's add some notes to our notebook. Here is our hovercraft design in case we want to try making changes to that again later. I really want to try building a jumbo hovercraft like Mr. C did. Wouldn't that be a fun way to play some tennis? I also made a note about bowling alleys using wax to reduce friction. I wonder if there are places where you might want more friction instead of less friction.
Here's a challenge, Mr. C. You have 2 containers filled with rice. Can you lift each bottle using only a skewer stick? Is it possible? Let's find out.
All right, so I've got 2 containers here that both have rice in them. And the question is can I take a skewer stick and lift up this container of rice? Is it even possible? Let's give it a try. Wait a minute. I thought that was gonna work. Let's try this one. What? It works. And you might be saying to yourself, why did it work? And the answer is friction! F-R-I-C-T-I-O-N, friction! Friction allows us to lift up this container of rice simply with a skewer stick. What I did was I packed this down really well before I filled this one up so you didn't see me. This one actually has more rice in it. And what I did is I literally compacted the rice over and over and over so that there weren't nearly as many gaps. This one is really difficult to pull out. This one pulls out super easy. I know what you're thinking. What would happen if we did it with this 2-liter bottle? Will it actually work? That's a lot more rice. So I have a little bigger of a stick to try. All right, here we go. Ah, I'm nervous. Here we go. Science! It worked. It's working. That's the power of friction. Have some fun at your house. Use this science to trick a friend or a family member. And always remember, it's about friction. F-R-I-C-T-I-O-N. Friction.
Don't get salty. You can use the power of science to figure this one out too. In this container, we have a marble that is completely covered in salt. Is there any way to get the marble out without dumping the salt out too? might just look like a bunch of shaking, but that shaking is causing a lot of friction to happen inside that container. That friction is actually causing the marble to move upwards with every shake. Eventually, the marble reaches to the top, and you can carefully roll it out without dumping any of the salt. Challenge your science crew and see if they can figure out how to harness the power of friction to do this trick.
Take 2 sheets of paper out of a notebook. And then I want you to rub them together. It feels really smooth, so you don't think there's any friction occurring. But there actually is, because these 2 pieces of paper aren't perfectly smooth. They're actually really rough, but it's really hard to see that. What we're going to do is we're going to take multiple sheets of paper and stack them together to see how powerful friction can really be. What you're going to need is 2 new or used notebooks, or books, or anything like that. Flip open one of the notebooks, flip open the second, and you're going to lay it just like that. What we're going to do is we're going to alternate sheets of paper one at a time until we get the entire book laid on top of each other and interlaced. Here we go.
Five minutes later.
All right, so we folded the papers on top of one another. Took a little bit of time. This is gonna keep popping up, so I'm just going to put a small piece of tape on here just to hold this down, just so it doesn't pop up. I'm gonna do that on the back also. All right, so earlier we were able to say that the pieces of paper rubbed across one another really easily, and they slid over each other. So the question is can we pull this apart? Let's try. There's no way. There's no way. And you're probably wondering, why can't he pull it apart? It's because of friction. Although these 2 sheets of paper, well, the other one flew off the, oh, here it is. Although these 2 sheets of paper move across one another very easily, when we stack them over multiple times, over and over and over, it starts pushing that paper together. And because it's rough, it doesn't allow it to move easily. And now when I try to pull this apart, it's almost impossible. Well, I don't think I can do it. Give it a try and see if your friends and family are strong enough to beat friction. Whew, that's a workout.
Here's a fun experiment you can try at home. Build a ramp and then find objects to place on the ramp. Slowly lift the ramp until the object begins sliding. The moment it starts sliding is the moment the force of gravity overcomes the friction holding it in place. Test different objects to see which creates the most and least amount of friction with your ramp.
This is one of my favorite toys, and it is a fidget spinner. That's right, this thing spins and spins and spins, and it's all about the bearings it uses to make it go round and round and round. Well, we typically want friction while we're walking and driving our car, so we're not slipping and sliding all over the road. Reducing friction here allows this to spin really easily. But to understand how it works, we need to look at a bearing and what it's really composed of. So this bearing here, we're gonna pop this open, and right away we're gonna see all these little bearings inside. These are steel ball bearings. There are 7 of them in there. And you can see they actually rotate. So they're in there, they're rotating on an inner cylinder, and they're touching the outer cylinder, and this reduces friction. Now you might not have one of these lying around the house, but you might have something like marbles. So here I have a little container with some marbles in it. And you might be saying, what is he doing? I want to show you something. So let's take this piece of wood. I'm gonna put this wood onto the table. I'm gonna spin it. I'm gonna try to spin it again. It maybe gets one rotation. It doesn't spin very well. You can actually make your own bearing to decrease the friction that this wood is experiencing. Take a lid from an empty container, throw a few marbles into it. Then take your piece of wood and put it on it, and then rotate it. Isn't that awesome? It literally reduces the friction. This wood is gliding over the top of these marbles, and it's acting just like a bearing. We can add more to make it more stable so that it's balanced. And now when I put it on there, I can spin it. Oh, there we go. The problem with marbles though, they're not all perfectly the same size. So what I have here are some actual steel ball bearings we're gonna try it with. Here you can actually put it right on here and you can see how it spins. Pretty cool, right? That's the power of a bearing, the ball bearings. And these reduce friction.
Well, the force has certainly been with us today. I've added lots of notes to our notebook. Salt, rice, paper, and even air can all have an impact on friction. I made a list of the objects we tested on our ramp. I'm wondering if the results would have been the same if we tried putting them on the slide at the park. Hey, Mr. C, do you know why the chicken crossed the playground? To get to the other slide.
Not only can we test friction by putting an object on top of the ramp and lifting it to see when it starts sliding down, but we can actually do the opposite and build a ramp to see if objects can crawl up the ramp to see whether or not there's enough friction. I've built a homemade ramp here, and it has 3 different surfaces. I have a clear plastic sitting on this part of the wood. I have some tape that's sitting here in the middle, and then this part has nothing on it. This is just strictly wood. And what we're going to do is I have all these wind-up toys, and we're going to see whether or not they can actually move up the different surfaces. It's all about friction. So let's start here with the plastic one first. I've got my little wind-up toy. And it's not really going anywhere very fast. I'm gonna wind it up again, and I'm gonna put it on the tape. Oh, and it goes, and then once it hits the plastic, it no longer has enough friction to continue moving up the ramp. You okay, little buddy? He's like, no! All right, so he's actually, there's enough, what's interesting is there's enough friction for it to sit right there without it sliding back. I'm gonna leave him sit right there. All right, so we have this ladybug looking wind-up toy, and we're going to put the ladybug on the plastic. Just goes backwards. So then we're gonna try it here on the tape. And it works on the tape a little bit, but then on the wood, it's just spinning out. There's not enough traction, there's not enough friction to cause the ladybug to move forward and to go up the hill. All right, we're gonna let you unwind. All right, unwind. But this one here is still sitting here. I'm gonna take this one off. Look, it still has energy. But I'm gonna put this on the wood to see if it actually can go up the wood. No, so far out of our 3 tracks, the tape here is the only one that we've been able to go up. Let's try one more. I've got this little frog that's standing on his hands. Let's see what he can do. He's trying to walk. You can see he's moving up just a little bit, but then he starts sliding. Actually, no! That actually was working pretty well. Let's try it on the tape. Works pretty well on the tape. Go Go, go. All right. So now let's try it on the wood. This is the only one that's had any success on the wood. And I wonder because it's more like hands that are gripping versus the wheels. Oh, all that work to go back down the ramp. It's all right, little buddy. So this is a really cool, fun way to explore different types of surfaces by creating your own surfaces. So I use plastic and tape and wood. What do you have at home to create your own friction ramp to test the toys and things that you have at your house? Remember, everything you did today and joined us with, we want to put that into our notebook. It's a great place for us to reference and go back when we have questions about what we already learned. Keep learning, keep exploring, keep having fun, and remember, science is wherever you are. See ya! It's science time. F-R-I-C-T-I-O-N. Friction. F-R-I-C-T-I-O-N. Oh, that was really not good rhythm. Can I start over? Ow. Oh, that was my knee. All right, take two.